This lecture comes from the chapter on safety and specimen preparation, but we are just going to focus on specimen preparation and in particular dilutions. Knowledge of dilutions, and especially serial dilutions, is essential to understanding our serology testing in the clinical lab, since the relative proportions of antigen and antibody present are very important. A dilution involves two entities, the solute, which is the material being diluted, and the diluent, which is the medium making up the rest of the solution. In the solute is usually serum from our patients in the lab. Why do we need to dilute patient serum samples? Because the results may reside outside the linear range of our instruments, and we need to determine the titer. So how positive is it? How hot is the sample? So let's talk about some of the terms on this slide again. So in the clinical lab, most of the time we're going to be having to dilute the serum in our patients. So that's going to be the solute. The diluent, now you've probably heard about different diluents, water, saline, but most of the time in the clinical lab, we use saline or a bovine serum albumin solution. And there will be in the procedure manual for each test what the diluent needs to be for each sample. Most of our dilutions that we do are in the chemistry lab and the serology lab. And what does outside the linear range means? That means that our instruments are only sensitive enough to measure analytes within a certain range. So let's use glucose, for example. The linear range may be from 10 milligrams per milliliter of glucose all the way up to 1,000 milligrams per milliliter of glucose. But what if a patient has a glucose that's over 1,000? We would have to do a dilution. Or titers, we would need to do a titer. So if somebody comes in and they have they think they've been exposed to an illness, or let's take your hepatitis B vaccine, for example, you may have to do, your titer may not be high enough. So we would have to check it and then come back again and do it again to see if there was a change. So sometimes we're looking for a change and we have to do a titer. The relationship between the solute and the diluent is expressed as a fraction. For example, a 1:20 dilution or 1/20 dilution contains 1 part of solute, which would be our serum usually, and 19 parts of diluent. So 1 part of solute over 1 part of solute plus 19 parts of diluent would be 1/20. So we get our 1:20 dilution. The number on the bottom, or the denominator of the fraction, is the total volume. You need to write that down, keep it in mind, because that's where students make their mistakes if they're going to make mistakes. The sum of the volumes of the solute and diluent combined, as in 1 over the dilution equals the amount of solute over the total volume. Compound dilutions are just a dilution of a dilution. That's the definition of a compound dilution. And why would we need to do this? Because occasionally in the lab, we need to make a very large dilution of a patient sample. And it's more accurate and less costly to do this in several small steps rather than all at once. Such a process is known as a compound dilution, or a dilution prepared in several stages. To calculate a compound dilution, the first step is to plan the number and sizes of simple dilutions necessary to reach the desired end point. What's the final dilution that you want? Such a dilution is made using very little diluent in a series of test tubes, rather than having to use a large volume of diluent in a flask. So let's say we need to make a 1 to 1,000 dilution or even a 1 to 100. You wouldn't want to take 1 microliter of our patient serum sample and a 99 parts of diluent. That's room for a lot of error because it's really, really hard to pipette 1 microliter, and 100 microliters total volume is not enough to test. However, the volumes are kept small enough so that mixing can take place, and the final volume per tube is planned to yield the volume that is necessary to perform a test. And what I mean by that is, on a lot of our analyzers in the lab, there is a minimum volume required of sample. So if we make a total volume of 200 microliters for our dilution, but our analyzer requires 500 microliters or half a mil, that's not going to be enough. So you have to plan what final volume you need based on the minimum amount required to even run the test. If in each step of the dilution factor is exactly the same, this is known as a serial dilution. Serial dilutions are often used to obtain a titer or indicate an antibody's strength. So a series of test tubes is set up with the same amount of diluent in each tube. So in this tube, they have placed 0.2 milliliters of diluent in each tube. So there's 0.2 diluent already in there, 0.2 milliliters of diluent in every tube, 1 through 6. So then you add 0.2 milliliters of serum, mix, then you remove 0.2 milliliters of our 1 to 2 dilution, put that in the next tube. So now you have a 1 to 2 and a 1 to 2. That's a 1 to 4. I'm going to do a separate video and draw this out. But you end up with a ×2 dilution in every tube, but each time it's compounded. So 1 to 2 times 1 to 2 is a 1 to 4, and 1 to 4 times a 1 to 2 is a 1 to 8. A 1 to 8 times a 1 to 2 is a 1 to 16. A 1 to 16 times a 1 to 2 is a 1 to 32, and a 1 to 32 times a 1 to 2 dilution is 1 to 64. So our dilution factor is 64, and if we ran this on our analyzer, we would multiply the number that came from our machine by 64, because that would have been the final dilution that we ran. The most common serial dilution is a doubling dilution, or 1 to 2, in which the amount of serum is cut in half with each dilution. Having the ability to work with simple and compound dilutions and to interpret serial dilutions are necessary skills for working in immunology. So let's go back and review some information that we've already learned. So innate immunity includes what? Is it an anamnestic response? Does it include antibody production? Does it include cytotoxic T cell activity or phagocytosis by polymorphonuclear cells? Now, I love explaining this anamnestic response because a lot of students are like, what? What is that? So if you know what amnesia is, that means you forgot, right? You can't remember anything. So if it's an anamnestic response, that means it does remember. So that's a memory response. So we know that innate immunity, does it include memory? Does it include antibody production? Does it include cytotoxic T cell activity or phagocytosis? I hope you picked phagocytosis. That is an innate immunity function. Which of the following statements about the test for CRP is true? It correlates with neutrophil phagocytic function. It's an indicator of ongoing inflammation. It is diagnostic for rheumatic fever, and levels decrease during heart disease. Well, we know that it is an indicator of ongoing inflammation. It doesn't have anything to do with phagocytic function. It is not diagnostic for any specific disease, and levels don't decrease during disease, they increase. A cut on a person's finger becomes contaminated with the bacterium Staphylococcus aureus. What is the first response by the immune system? Would it be B cells, monocytes, neutrophils, or T cells? Man, this is kind of a tough one. Neutrophils. That is going to be the first response of the immune system. Okay, now the final question for what we learned today. An antibody titration is depicted in color plate 25. Here is color plate 25. In this titration, a 0.2 milliliter aliquot of a patient's serum sample was added to 0.8 milliliters of saline, and this mixture was placed in tube 1. So in tube 1, you might want to get out a pencil and paper and draw this out. So in tube 1, we have 0.8 milliliters of saline and 0.2 milliliters of a patient's serum. Then you have 0.5 milliliters of sample removed from tube 1 and placed in tube 2 that has 0.5 milliliters of saline. Okay, so what is our dilution in tube 1? We have 0.2 milliliters of serum over 0.2 milliliters of serum plus 0.8 milliliters of saline. So that would be 0.2 over 1, and I believe our dilution is 1/5. Okay, so our dilution is 1 to 5. Now, in tube 2, you took a half mil from tube 1 and placed it in tube 2, containing 0.5 mils of saline. So they repeated this process through tube 10. So tubes 2, 3, 4, 5, 6, 7, 8, 9, and 10, they have a 1 to 2 dilution. All right, so I'm going to give you I would pause the video, try to work it out, and see what you get. One to 640, because it asks, how should the antibody titer be reported? And the last tube that showed any positive reaction was tube 8. And so your dilution for tube 8 should be your answer. All right, and we're going to do some more work on this in class, so do not worry.